This is really of interest for a lot of you who are biologically oriented, and that's the idea of a concentration cell. And the reason why this is going to be interesting is because concentration cells is essentially biological electrochemistry. And so that's why I wanted you to review this topic of a concentration cell. So first of all, we should begin with what a concentration cell is. And so the definition of a concentration cell is a cell that has the same half reactions in both half cells. So both sides of the voltaic cell are going to have the same half reaction. So how would you get a potential difference between those two half reactions? And the answer is that they're going to have different concentrations. Because as we just learned with the Nernst equation, if you have non-standard conditions, then you're going to have a different cell potential. So if you have two half cells, even if one of them is at standard conditions, but the other is not at standard conditions, then you're going to lead to some difference in potential between the two half cells. So because of this, the standard cell potential is going to be 0. Because if you take the cathode and the anode, they're essentially the same half reaction. Whatever potential they are minus the same potential is 0. So that's another characteristic of a concentration cell. So because the standard cell potential is 0, but we have at least one non-standard condition, we can use the Nernst equation to do this. Now biologically, where you see a concentration cell come into play goes back to the idea of electrolytes in your system. So what kinds of things are pumped into and out of cells? You're going to have ions. You've probably learned about the ion channels in your cells. You have sodium, you have potassium, you have calcium, for example. Those ions have charges. And so we get essentially little mini concentration cells when we compare essentially the inside and the outside of a cell as the two half reactions, the two half cells. So we have one concentration of ions inside the cell and a different concentration of ions outside the cell. You have different concentrations, so you get some potential difference then between the inside and the outside of the cell. And those tiny little potential differences are responsible for a lot of the biological electrochemistry that goes on in the body. So I just wanted to introduce that to you. And a lot of the biological cell potentials are going to be on the order of, for example, millivolts. So they're not really large amounts of potential difference, but you can still get biological work done with those small potential differences inside and outside the cell. So when you're doing some kind of monitoring of your patients, and you're monitoring an EKG, and you're trying to find what's going on in the heart, for example, those little electrical impulses are due to ion differences between the insides and the outsides of the cell. So that's where electrochemistry can still be useful to all you biologically oriented students. And I think in medical school you would deal more with that, but for now, just be aware of what a concentration cell is, and that when you're using concentration cells, you can find the cell potential using the Nernst equation. The Q in the Nernst equation would come in from the concentrations inside the cell and outside the cell, the intracellular fluid and the extracellular fluid. So that's how you would determine the Q, which would then play into the Nernst equation. So any questions about concentration cells in general? So if you're ever stuck on a desert island and you need to make some electricity and you have salty seawater around, if you could find a way to change the concentration of the seawater in one part of the cell, you could make a tiny little battery on an island just with seawater. Concentration cells. And then you could power all your iPods so you could listen to music while you're stuck on the island.